Hydrogen. Hydrogen just simply gets a dot. Next over, you can have, let's see what's a good color for that. Well, for 2 bonds, you can have, I'm doing the moon. Let me show up, need markers. Two bonds could be a moon. We did it as a football the other day. Magnesium, right, those. So it can be a football, or lastly, we even did for 2 bonds was a horseshoe. So these are all group 2. Hydrogen's 1, so lithium, all those guys. Now group 3, this is what we came up with the other day. For boron, we're going to give it the isosceles triangle so that you got the 120 degrees. Okay, so see that there's 3 bonds to that. So now when we come over next, first we got a carbon in between there, so that's the carbon diamonds here. Four bonds on the carbon, right? So, check our red. Our markers are disappearing here. What our colored pencil is, okay? So B with 3 bonds. Hone in a little bit on this. So there's 1, 2, 3. These guys are 2. 1, 2. The football. 1, 2. Or even the horseshoe. Now the horseshoe is cute, but it doesn't quite do the, because the geometry, you really want them on the opposite ends. So the moon was cool. We're trying to work on quarter moon because it's not 4. So here's 3 bonds. Carbon's going to have the 4. This would be methane, equivalent of. Okay, so what we just came up with, to give this to 120 degree, we made nitrogen. Number 5, we're going to put 3 in paren because it's only got 3 bonds. So we're going to give it a right angle. And it's going to have 3 bonds, but then we bring in the lone pair on this. 1, 2, 3. So we put all the lone pair of electrons in there, though. Because that baby is able to bond other ways. Let's color some of these a little bit better. Carbon, nitrogen, right? Nitrogen, marker here, N. So see, the color coding works really good on this too. Black for carbons, and we do different colors on the carbon depending on the type of atmosphere that it's in. Single bond, double bond, etc. Boron, what's underneath boron? Aluminum. So aluminum is going to do the same thing with the 3 bonds here. So you could say like aluminum, 3 bonds. So the aluminum like boron. Now this would be something like calcium, magnesium maybe, barium it could be. So these could be different number 2s. We got 3s, we got 4, we got 5. Now oxygen's really good because it's 6, but really it's 2. So when we draw O here, 2 bonds. So what's nice about the O is you draw many lone pairs in here. There's 1, 2. So it's like a double 2-headed alien. When it gets ionized, we draw a big number 3 in there, but for now, oxygen's always got the 2 bonds, so we'll kind of leave that as it is. Here's another green. We found all the best colors of these giant crayons in our recycle adventures. So again, kids, this is all from recyclable materials that we got here. From the crayons to the blueprint paper to the markers, except I did buy some new markers. So the aliens, you can color those in a little bit if you want. So again, the 2 bonds on the O here, what would those be? That'd be H2O, right? So 1, 2. That'd be H2O. Now underneath N, this is where our first great discovery came. Phosphorus markers. About these. Phosphorus has 5 bonds that it can do, or 3, but so see that? 5 bonds. Let's just use those, even though you never find this because it's too big. But 2, 3, 4, 5. So this is underneath underneath nitrogen. But then when we looked underneath oxygen, sulfur can have 6 bonds. So we came up with the old Star of David here. 6 bonds on that. 1, 2, 3, 4, 5, 6 bonds on sulfur. So isn't that neat how the star comes into play here? 5-pointed star for the phosphorus, 6 for the sulfur. This is fun stuff. And we're still working on it, but I think green has to be it because it's in the same family as the oxygen. So there's sulfur, phosphorus. Now what we did for helium, we even found we can do it as a sun. Just since we're doing shapes here, huh? So helium is just the sun. And our sun is actually a yellow. Yellowish orange our sun is. And don't let them tell you our sun is a typical star, because it is not by a long shot. For one thing, it's an independent. Everybody